Hello everyone, this is Murli. Welcome back to day 4 of the challenge. We are discussing about the case study application in the context of the 100 days full stack application challenge. And yesterday we discussed about a very high level markup of the application that we are going to build and not the full app at this moment. We're just looking at the first step of the MVP and we called it as continuous accessibility. That's the full name of our application. Today we will focus on thinking about the architecture and of course a cloud provider as well where we can deploy this application. Before we do that, we need to identify what kind of initial services that we need to set up and also pick up what kind of technology stack that we would like to use for this application. So let us go ahead and get started with the discussion. As we discussed yesterday, this is a web page where user will enter the domain name and click that button and we go and run the test and send the results back. So on the surface, we need a web application. So we need a website or a web page where user will be able to enter the website name. So we will call it as, typically called as a front end. Web app. And we need a service on the back. We'll call it as test service, a test API service. And we also need a data store that will allow us to store the results and the test runs and all kinds of stuff. We'll call it as a data store. So when the user enters the website and clicks on the check button, the front-end application will communicate with the API, send this domain name to the service. Service will probably store that website information first and then run the test, store the results back, and prepare the scorecard and gives the final results that we could use to send it back to the UI. So then the UI will display the scorecard and other details. So this is a very high-level service. So we need a front-end application to start with. This is the front end. We need at least one service that accepts this input and then run the tests and then stores it into the database. So we need some kind of a data store that we would like to use. So it is a very traditional web application, if you will. If you have worked on any kind of web applications, typically referred in architecture-wise, could be an Untitled architecture or a microservices-based architecture. We will talk a little bit more about the microservices architecture and other aspects a little later. But at the moment, this is all we need. So you can pick lots of varieties of stack or the solution architecture that we could use. Very high level, you could go with a server rendered application and examples like ASP.NET, for example, is a server rendered application. Ruby on Rails is another one, which is server rendered web applications. Typically, not that either of them cannot support APIs, but typically the web applications built using stacks like ASP.NET are server-side rendered. Or otherwise, we could also use the concept called Jamstack, which is a JavaScript API and markup, which will be what we also call as SPAs or single page applications. These are pure front-end applications that run within the browser, communicate with the backend services via APIs, and then interact with the services on the backend. So there is no server required to host these single page applications because these are pretty much like static web pages. Compare that to a server rendered application where you need to have a server running 24/7 to be able to process the traffic. So in our case, I'm going to go with my choice of the stack, and you're not limited to follow the same stack I'm going to use it. You go and pick the stack that you're comfortable with, because as you know, looking at the application specifics, you can figure out what stack will work for you. Or if you're new, you can pick which you're comfortable to learn and then build it. So for me, I'm going to follow the Jamstack approach, which means I'm going to build an SPA using Angular. And on the back end, I'm going to use a Node.js stack to build a REST API service. And that is going to provide the API to the front end, and front end is going to consume that. And for the data store, I'm going to use DynamoDB for now. And this is AWS DynamoDB. This allows us to go completely serverless stack. That means we are not running anything 24/7, and we only pay for usage. So for example, for this specific stack that we are going to use, we may have to pay maybe $1 a month if you have like thousands of users, but otherwise you pay zero pretty much. So that's why I picked the serverless stack. But you don't not limited to this specific aspect of it. You can pick whatever you want. You can have the server, you can use container-based services like ECS, Kubernetes, anything that you would like to use for our service. It's really simple, and we don't need to go crazy on the technology stack. Just use a pure serverless stack, which is going to be much easy to work with and cost next to nothing. So I just talked about what stack I will use to build it. To host it, I'm going to use it as a static web page, which means I will be publishing the application to S3 bucket and put in front of it CloudFront distribution. This will allow us to distribute our application as a web application in all the CDN provided by AWS endpoints across the world. So that means our application is really fast to load no matter where they're accessing it from. So this is like, I'm using some very high level and loosely calling them with these terms, but you can refer to it as CDN, Content Distribution Network, which makes it easy to access this application from anywhere in the world. So we're going to use S3, and we'll use CloudFront as a distribution. Node.js, the REST API, I'm going to use AWS Lambda, which is a serverless compute, so that I don't need to run a server 24/7. And as I mentioned, for database, I'm going to use DynamoDB. So this is it. This is a very high-level stack that we are going to use. And this stack is pretty much 100% serverless at the moment and costs nothing, literally nothing until you acquire thousands of users. But for the first 100 users, you probably pay nothing to AWS to host this application. And as you go forward, you may be able to add additional services and all, but for now, this is good enough architecture for us to go get started and evaluate our hypothesis and see whether really it works, and we can acquire customers to be able to use it. So that's all. This is the day 4 about the architecture. We're going to use a serverless architecture with microservices. Even though we are just building one microservice at the moment, we will be able to build additional microservices in the future as needed. And the architecture doesn't change. We just add another Lambda service and be able to use it. And of course, to be able to expose APIs to our front-end application, we're going to put an API gateway in the front. And that will allow us to scale to any number of microservices as well. So that's it. That's all about the high-level architecture. We'll get started and get going.